This video is going to cover questions 16 through 30 of the 2015 released SOL. This covers all the questions that are in reporting category number 2, which deals with triangles. So let's remember those strategies we talked about from the last video. We want to find the key word. Remember, that's which, what, select, find. Our key word here is which set of coordinate pairs could represent the vertices of a triangle congruent to triangle KLM. So we're looking for congruent triangles. Remember, congruent triangles have equal or congruent sides and congruent angles. So probably the easiest way to do this would be to figure out how long each side is, and our other triangle is going to have the same dimensions. So we see that LM is 3, KM is 4. If we want to find out what LK is, we have to use the Pythagorean Theorem. So 3 squared plus 4 squared, and we should know that's 5 squared. So LK is equal to 5 units. So we're going to try graphing these 4 sets of points, and we're going to see which one looks like it has sides of 3, 4, and 5. So let's start off with letter A. We can use our point tool to help us out here. A is 0, 0, 3, 4, so we go over 3 and up 4, and 0, 5. So at first glance, it might look like this one is going to be our answer. But if we take a look, we don't have anything that is straight up and down with the exception of this side here, which is 5. We should see pretty quickly that this side right here, which I'll color like that, that's not equal to 3 or 4. So right away we know that A isn't the correct answer. Remember, all the sides need to be congruent. So I'm going to erase this, and we're going to try a different one. So let's try letter B. We have 0, 0, negative 5, 0, and 0, 4. Now, just from first glance, we should see this is too big, and it is. Whenever we think about it, this side's going to be 5 units and 4, and our third side is definitely bigger than 3, so this one also doesn't work. Let's try letter C. So for letter C, our points are negative 1, positive 1, negative 4, positive 5, and negative 1, positive 5. So this one's looking promising also, because this time we have lines that are vertical and horizontal. So we can count those. This side here is going to be 3. This one here is 4. And our last side is going to be 5. So we see that we have congruent triangles. This would be by side, side, side. All 3 of them have we have 3 pairs of congruent lengths. That's good enough to say they're congruent. So C is the right answer for this one. Here's another one that deals with triangles. So the key word here is select 2 relationships that would prove the triangles are similar. Remember, this symbol right here means similar. Triangle ABC is similar to triangle QRS by side angle side. So let's give a few of these a try. Let's assume that A is congruent to Q. Let's see if that one would work out. Well, if that's true, I'm going to use tick marks here, which probably isn't the best notation. We need these 2 sides to be in proportion. So we need AB over QR to be there. and we need the other two sides, AC over QS. Again, that's not congruent. I would need those sides to be in proportion. So do I have that anywhere? And I do see that if we do have A is congruent to Q, we have AB over QR is equal to AC over QS. So our answer came pretty easily to us with this. We have to try the different angles and then see what works out. Another one that would be an answer that isn't one of our options. So if we had angle C is congruent to angle S, we would also need two sides to be in proportion. So this time, if we had C and S, we would need BR to be over RS and AC to be over QS. Remember, the same triangles in the numerator, the same triangles in the denominator. Since we don't have that match up, that's not an option. That's just another potential answer that could be here, which isn't. This one here, again, we want to start off by looking for our keyword, which is the length of a side of a square. Well, we need to read the other information here. It says the diagonals of a square measure 14 centimeters. So the diagonals are 14 centimeters. So let's draw a square. We know a square has 4 right angles. We also know that all 4 sides are congruent, and our diagonal is 14 centimeters. So how do we solve this? There's a couple different ways to do it. Let's first just break this triangle out. So you should see that we have a right triangle with x and x. So we should see that it's the Pythagorean Theorem. X squared plus x squared is equal to 14 squared. So we have 2x squared is equal to 196. We divide by 2. X squared is equal to 98. Take the square root. So whenever we type this in our calculator, one option that we're going to get is we get this 9.899 that goes on forever. Well, if we type those values in, we will see that 7 square root of 2 is the exact same thing. So that'll be our answer. If you want to break this down into how we get the actual answer, all we have to remember is this is equal to 49 times 2. So when we take the square root, square root of 49 is 7, so that's how we get 7 square root of 2. The next problem says what values of x and y make these two triangles congruent. Well, let's see if we can figure this out. We know that n is going to be congruent to r. So here's angle n, there's angle r. So we do 1.5y is equal to 41.4. So to solve for y, we just divide by 1.5. And we get y is equal to 27.6. So right away we can rule out a couple of these. And now we need to solve for x. So x comes on side nm. NM matches up with PR. So that'd be this side right here. So we do 3x minus 9 is equal to 24. We add 9, get 35, and we divide by 3. Sorry, this is 33. So we get x is equal to 11. So the correct answer is B. So moving on to question 20, it says based on the given information, which figure, so there's our keyword which, figure contains a pair of similar triangles. So there's a number of different ways we can prove triangles similar. We had angle-angle similarity, side angle side similarity, and side 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 similarity. So the easiest one's angle angle. If we have two angles that are congruent, two pairs of angles, then the triangles will be similar. Well, we see vertical angles right here, so we have two angles in each triangle. So just like that, we're done with question 20. It's A, angle angle. So number 21 says a right triangle is shown. Here's our keyword. Which angle measure is closest to the value of x? So whenever we have or need an angle in a right triangle, we have to use trigonometry. We have to use SOHCAHTOA. So here's the angle, and we want to label our triangle H, O, and A. So remember, across from the right angle is H, and opposite and adjacent. So we have O and A. We don't have H. So we're going to use tangent. So how we set this up is we write tan, and we always put the angle next to tan, which is going to be x. So this is the angle. We don't always put x, we always put the angle. That's equal to opposite, which is 8, over adjacent, which is 7.8. In order to solve this, we have to take tan negative 1 of each side. So x is just going to be equal to tan negative 1, 8 over 7.8. When we type that into our calculators, make sure your calculator's on degree, by the way, we get 45.7. Which is C. Question 22, we want to find that key word. What is the correct order of the lengths of the streets from longest to shortest? So we want to find the longest side to the shortest side. To do this, we need to find the largest angle first. So we need to figure out the missing angle. 180 minus 54 minus 64 gets us that missing angle of 62. So to find the longest side, we pick the biggest angle. So this is the largest angle. And we go across from the largest angle. So our largest street is Rector. Our next largest angle is 62. Across from that is Pine. And our smallest angle is 54. Across from that is Taylor. So the order should be Rector, Pine, Taylor. We start this problem off by looking for the keyword, which represents all possible values all the possible values in yards of D. Notice if we do this, we don't even need to look at the top words. We already have the picture. So the picture is enough to solve this. In order to solve this problem, we take the two lengths that we have, we subtract them, and we know that the range is between the subtraction and the addition. So whenever we do that, we get 21 and 147. So our answer is just C. This problem says select the measures that could be the three side lengths of a right triangle. So we have to use the Pythagorean theorem. A squared plus b squared equals c squared. So let's try some things out. Let's try 17 squared plus 20 squared. Whenever we do that, we get 689. The square root of 689 is about equal to 26.2, and it goes on forever. So we see that that's not going to be a Pythagorean triple. 17 and 20 aren't going to be our answers. So we have to try something else. Let's try 17 squared plus 21 squared. This gets us 730. The square root of 730 is 27.01, and it goes on forever. So it's not going to be 17 squared plus 21 squared. The last option we can try is 20 squared plus 21 squared, which is 841. The square root of 841 will get us 29. So that'll be our three answers, 20, 21, and 29. Remember, the largest number has to go across. It has to go to the hypotenuse. So our answers could be 20, 21, and 29. Remember, it doesn't matter where these other two values go. We could have 21 and 20. Those are both good answers. The bottom line is we have to have 29 as our hypotenuse, and 21 and 20 can be moved around. So find the key word. What measure of angle P could be used to prove triangle LMN is congruent to triangle PQR? So whenever I take a look at this, M and Q are both in the same position. So that means 2x minus 26 is equal to x plus 16. So I subtract x from each side. X minus 26 is equal to 16, and add 26. X is equal to 42. Now, a lot of you are going to be tempted to pick 42, but it says, what measure of angle P? So to find angle P, I need to continue doing work. Remember, this is an isosceles triangle, so these two angles are going to be congruent. Angle Q, the measure of angle Q, is equal to x plus 16, which is equal to 42 plus 16. So it's equal to 58 degrees. So if I want to finish this, I need to say, we'll call it y plus y, so we're going to call these two y's, plus 58. I need to erase some lines, so I'm going to erase this work. Just bear with me for a few seconds. So y plus 58 is equal to 180. 2y plus 58 is equal to 180. Subtract 58. We get 2y is equal to 122. And then divide by 2, which gets us x is equal to, or y I should say, 61. Well, we ran out of lines. There we go. So that one there has a lot of steps, but it all comes down to making sure that you read the problem correctly. We find the keyword to start this problem. List the interior angles of triangle RST from smallest to largest. Well, we have to use this given information here. And since we don't have a triangle, you want to draw one. It's triangle RST. So at all the three corners, or vertices, we write RST. RS is 14, ST is 10, and TR is 16. So we're listing them from smallest to largest. So we find our smallest side. This is our smallest side. And we go across. So our smallest angle is going to be angle R. Our next smallest side is 14, so our next smallest angle is angle T. And our largest, 16, goes to S. So it should be angle R, angle T, and angle S. So for this problem, it says which of the following sets of side lengths could be those of triangle LMN. Well, what's special about triangle LMN? Triangle LMN is similar to this triangle. So whenever we figure out similarity, we have side lengths, we should be thinking of side, side, side similarity. So that means I'm going to write 3, 4, and 5, and I need these fractions to be equal. So I'm going largest, or I'm going smallest to largest. So is this equal to 2, 3, and 4? You should see that that isn't true, so A does not work. What about the next one? So we have 3, 4, and 5. Now we have 6, 7, and 8. Again, that one doesn't work. Let's try the next one. 3, 4, and 5. We have 8, 15, and 17. Once again, that doesn't work. So our last one, 3, 4, 5, we have 9, 12, and 15. All of these simplify to 1/3. So that works. We have similar triangles now. By side, side, side similarity. The sides have to be in proportion for the triangle to be similar. So for this problem, our keyword is which is closest to the value of x. So we see we have an angle. Just like in one problem we've already done, we're going to use SOHCAHTOA, trigonometry. So we label our triangle. There's the hypotenuse, opposite, and adjacent. We have the hypotenuse and the opposite. We don't have the adjacent. So that means we're going to use sine. So we write sine of 22 degrees. Again, we always put the angle next to sine, cosine, or tangent. It's going to be equal to opposite x over 15. Remember, when x is up high, you multiply the 15. So we get x is equal to 15 times the sine of 22 degrees. Once again, if you're doing this on the calculator, make sure that your calculator is in degree mode. So we get x is equal to 5.6.